In my last video, I built a homebrew tactile keyboard for my beloved Sinclair ZX81 computers. However, my disappointment in the video output quality was getting to a point I could no longer ignore. So in this video, I will build a simple mod for the ZETI in order to replace the RF output with a composite signal. A few caveats. This project worked well for me. Your mileage may vary. I use parts found in my parts bin and may not necessarily be the most optimal. There are many professional options available if you look. I am a digital electronics amateur and my primary goal is my own learning. I love to share the path that I have taken. But before I begin, we need to go into a little detail about the ZX81 video hardware. Let's start with a very simple overview of the composite signal. Since the ZX81 only outputs black and white, the composite signal is actually quite simple. I will highlight a couple of the most important parts of the signal, starting with the sync level, the lowest part of the signal, which is used to synchronize the electron beam at the start of the line or frame. Next is the back porch. This signal level is used to set the reference for the black color level. We can ignore the color burst part of the signal, as the ZETI doesn't have color. Then we have the line data, which will vary between the black reference level and peak level for white, followed by a front porch. There are well-defined standards for the different voltage levels across the composite signal. These approximate voltages range from -300 mV for sync, 50 mV for back porch, and around 700 mV for white, resulting in a total peak-to-peak of approximately 1 volt. Many computers such as the ZETI do not follow these standards to the letter, as the majority of TVs do a good job of adapting to the provided signal. Having made that statement, the original ULA differed even further from the standard in that it did not even produce a back porch at all, and many TVs do have a problem adapting to that omission. To see what a standard composite signal looks like, I connected a video game system to my oscilloscope. This device does shift up the voltage levels to simplify the circuit and save the cost of having a power supply that produces both minus and plus voltage levels. Here we see the sync level, the back porch with the color burst, as this is a color device. Then we see the scan line data and the front porch. First, it is important to identify the specific IC variant of the chip used to produce the video signal in the ZETI. I happen to have two ZETIs, one with each type. My Project ZX computer, actually a newer Timex Sinclair 1000 variant that I have been making mods to, has the newer 2C210E variant. I will hook up my oscilloscope to the output of this ULA, displaying a test pattern that I will use throughout this video. Here you can clearly see from the oscilloscope that it has a back porch, although we are still missing a front porch. Here you can see my oldest ZETI has the original Ferranti 2C184E ULA variant. You will notice that this composite signal is missing a back porch. It jumps right from the sync level to the scan line data. Notice the alternating high and low levels that correspond to the light and dark parts of each scan line. So why was all of this information important? The new ULA with the back porch can easily be converted to composite with a very simple circuit. The older ULA can also support a composite mod, but there is a more complex circuit that will introduce a back porch into the signal, as well as output the composite signal. There are several very good and inexpensive options and products out there for doing both the back porch and composite conversion. This fully assembled circuit and others can be found on Tindy or your favorite retro computer source. If your ULA doesn't produce a back porch or has gone bad, you also have the option of purchasing a modern functional reproduction. This replacement does generate a back porch, which can even be disabled through configuration so that it can work with a composite circuit that adds the back porch, such as the one I just showed. This device can also be purchased on Tindy or your favorite retro source. So, if there are so many high quality, fully tested, easy to obtain and install mods available, why would I want to build my own? Well, if you have to ask, you haven't watched my videos. I am all about taking a simple task, forgoing the effort of those who are more experienced and know what they are doing, and do it my own wonky way. So here goes. The first step is to take our basic circuit and mock it up on a breadboard for testing. We have 3 inputs that we will connect to the ZX: 5-volt power, which routes to the collector, ground, and the video input tied to the transistor base. Notice the use of a 200 ohm trimmer set to 100 ohm for testing. We will replace with a standard resistor for our final circuit. Then we have our RCA jack with ground connected to the outer shield and the output signal connected to the inner jack. Time to test. I hook up the breadboard to my now Franken ZX. I plan on keeping RF output, so I steal power from the second connection wire on the RF modulator. I connect ground to the ground plane of the ZX, and I steal the ULA video from the first connector of the modulator. To test our breadboard circuit, I have hooked up the composite output to the TV while also running the signal through my oscilloscope. I run my simple test pattern program, and I think the picture looks clear and bright. With that initial success, the next step is to take our breadboard circuit and transfer the circuit design into KiCad. If you are interested in my full process, from KiCad through FlatCam, then on to milling the PCB, please watch my video, Milling PCBs with a Genmitsu 3020 Pro CNC router. We have 3 inputs that we will take from the ZX: 5-volt power, video signal from the ULA, and ground. I route the power to the transistor collector. Then I route the ULA signal to the base and route the ground to one side of the resistor, continuing to the RCA jack ground. I connect the other end of the resistor to the emitter and also route the emitter to the signal pin of the RCA jack. Next, we shift to the PCB editor in KiCad. Here we lay out the components in a nice little package. We will then export this design as Gerbers so we can load them into FlatCam to create the routing G-code. Then on to the router to mill. And here's the result. Quite a charming little PCB if I do say so myself. Now we have all of our components ready to assemble: the PCB, a transistor, a resistor, and the RCA jack. After a quick solder job, I do have to admit, since this is a proof of concept, I rushed and didn't use flux. I noticed the difference in quality. I hook up both the RF and composite output to my TV so that I can compare the results of each. RF displays fine, Now we switch to Composite, and it looks good. It's overexposed on my camera, but in real life it looks good. A quick note, although the display on my LED monitor is bright and much better than the RF output, I notice that the low end of the composite signal from my circuit is compressed. You can see that on the oscilloscope trace. So for comparison, I broke out the old analog device for testing. Not as crisp and bright as the LED TV, but still crisp. So the composite mod works on my LED and CRT displays. It is good enough for my Project ZETI. Wrapping it up, I wanted to compare the output of back porch versus no back porch. The ZETI with the back porch is slightly brighter and slightly sharper. The computer with no back porch also has a curve to the display. I can definitely tell a big difference in perceived sharpness with the composite display. Thank you for watching this video. I hope it was informative. If you like this video, please subscribe and comment. Thank you.